Hello, everybody. Yeah, sorry about the clickbaity title. I got a little bit too. Uh, yeah, I hope you all are not too disappointed. Oh yeah. So I wanted to mention, like, normally I talk about ZK stuff, but today I'm not going to talk about so much ZK stuff. This is more like the ways that we can help improve like layer twos, not just ZK but optimistic as well. And like one of the things that like at the end of Val's presentation that you mentioned is that like it would be nice if we can have an Ethereum that has like optimistics and ZK rollups. I hope that I'm paraphrasing you correct. Okay, yeah, correctly. Yeah, and I totally agree with that. I think that like the ecosystem will be better if we have both solutions, because like some of them might have mistakes and it's good to have some redundancy and different directions to explore. Cool. Okay, so let's get started. Can you see my slides? Yep. Okay. Oh yeah. Cool. Okay. Right. So there's this kind of story in, or this kind of philosophical problem where like it's called a ship of Theseus, where this person has a ship, and every year they take something, they do some repairs on the ship. They like go to the ship and they say, I'm gonna fix the mast. And they take the mast away and they put a new one there, and they just throw the mast on the beach. And they do this every year. They change one piece, and like after like 20 years, all of the pieces from the ship have been kind of taken away and they've been replaced with something else, something better. And like the question in the story is like, which is the ship? Is the ship all the stuff that's being kind of thrown away that was originally part of the ship, or is the ship like all the new stuff, right? And that's kind of like what's happening with Ethereum when we're moving to layer 2, right? Because yeah, because like when we're moving to layer 2, we're starting to replace and improve different components. So like let's have a look at like some examples of these pieces that are being changed. For example, like the TX pool is being changed. That like right now we have a transaction pool that's like managed by the miners, and because of this, there's like the transaction pool is optimized so that the miners have to do like the minimum amount of work that needs to happen. But when we're going to L2, the transaction pool is changing such that like the miners don't like miners are no longer the limiting factor, so we can expect them to do more work. And like when we can expect them to do more work, that can give us like a lot nicer user experience. Like we can have instant finality and we can have transaction abstraction and things like that. I'm going to talk about that a little bit more later in the presentation. Another thing that's changing is like wallets. That like when we started, we had and externally owned accounts, which is basically a public key, private key pair, and this can hold funds. And like these wallets are kind of like, they're kind of like a little bit, sorry. Yeah, so these wallets are like, they don't have a lot of like security features. They're more like just basic, like do whatever you tell them to do. So I'm going to talk about that. I'm also going to talk about the execution engines, how the execution engines are changing. And like the kind of point of the title is that like now is our chance to change these pieces, and we can put new versions there. And when we put new versions, we can put better versions. And that's the key point here. That like now is the chance that we can make those changes. And like in the future, it's going to be harder to make those changes because there's going to be less of a kind of momentum to make them. And that's kind of like what I was trying to communicate with the talk's title. Cool. Yeah. So let's go to the next slide. Okay. So let's talk about one of these examples. Let's talk about like user accounts. So at the moment, users have ECDSA accounts, right? This is just a certain signature scheme that's optimized for layer 1, right? Users sign messages and they kind of transfer them. And like in this case, users have like, when I install an app on my phone, right? The phone tells me, oh, this app wants to have permission to do the following things. This phone wants to access your contacts. It wants to be able to read and write things to your hard drive or your storage SD card. And like, this is something that we can't do with externally owned accounts. And this is a problem, right? Because whenever you're doing something externally owned account, it's basically just signing whatever you send it. You can't say, I want this externally owned account to be able to move like up to $10 of DAI, but nothing else. Like that's like a nice user experience that we really need to have, right? And like this is one of the things that we can change. This is our chance to kind of change, where we move from like externally owned accounts to like smart contract wallets, where we can have this like escalating permissions. Another thing that's really important is like social recovery. So at the moment, like if you forget your private key, you just lose all your money. And this is like the worst user experience ever. This is like really scary for new users, and it's like it forces the UX of wallets to be really, really hard to onboard people, because you have to like constantly enforce, you got to store this, you got to remember this, you got to remember this, and like that just takes a lot. It slows people down, and it's kind of really annoying when new users are trying to join. Right. So these are all things that we can change when we move to layer 2. And like one of the ideas here is to replace ECDSA with a better signature scheme that works better for optimistic rollups, which I'll talk about in a bit. Right. And have this kind of like smart contract wallet with this escalating permissions. And this is a nice chance for us to kind of change and improve the way that we're doing things. Cool. Yeah. Another thing that's important is that like we have different layer 2s, and like right now it's really complicated for users to understand, like I have some money on Arbitrum, I have some money on Optimism, how can I move money from Arbitrum to Optimism? And like this is just a lot of work for new users. So there's a lot of things that we can do inside the wallet to kind of abstract this away from the user. Like for example, let's say a user has some money on Optimism, and they want to spend that money on Arbitrum. We want the wallet to be able to figure out, oh, I'm just going to use this bridge to instantly withdraw my money from here to Arbitrum to make the actual transaction, to get the ticket back, to get the ticket, and then it's done. And like this is another really nice user experience that we want, where users don't have to know what L2 they're on. They don't have to know about L2s. They just understand that, oh, I just have to make this transaction. I can sign it. And this is another thing that we can do, and I think it's pretty important that we try and do this. And we want to get to a point where we have like the same experience on layer 1 that we have on layer 2. Cool. And this brings us to the question of like bridges. So like this is another really important feature that we need to improve. So the idea is that like, yeah, we want to have bridges that allow this kind of instant withdrawal. And if we do, we're able to abstract away from the user the idea of being on different optimistic rollups or different rollups altogether. Cool. Yeah. Okay. So another fun thing that we have this like opportunity to change is like the transaction pool, right? And the way that transaction pool works right now is that like all the pools come in to the transaction, and the miner will just check the ones that give them the most fee and include those in the block. And this is really sucks because it forces everybody to use the same currency. It forces everyone to do this nightmare thing of like having to go and get gas. And like this makes wallets have to teach users what gas is and how they use gas. And like then you have to tell them, oh, you have to pay a fee, and they don't really understand who they're paying the fee to. Are you paying the fee to the wallet? Are you paying the fee to somebody else? It just becomes this really complicated thing that like we want to be able to extract away. And if we're able to replace the like default transaction sequencer that exists right now, where it's just like put the most money, with some kind of like cleverer way that figures out, oh, this transaction has a 0 fee, but I know at the end of the transaction I'm gonna get paid because this transaction sends me some money. So this is another thing that we can replace that will make like the user experience much better. Another nice thing that we would really like to have is like a way for dApps to pay for the users. That like, and this is kind of enabled by the same thing. That like, if I'm a dApp creator and I make my own version of Uniswap, I deploy it on Optimism. I can deploy that. Yeah, I deploy it on Optimism. Then I use that to. Yeah, I deploy it on Optimism. Then I can use that. I deploy it on Optimism, and I want my users to be able to use it. And I want my users to be able to use it so that they don't have to pay gas, because I want to have like a lot of users, and like forcing people to get gas is really, really difficult. So one thing that we can do is we can make a smart contract that like at the end of a transaction will pay the gas for a user that uses my Uniswap. It's just like kind of like a Uniswap airdrop, but it's kind of the other way around. That like it's just free transactions for people as opposed to like giving money to people who have made transactions in the past. And like this is also enabled if we're able to change the transaction pool to be something that's cleverer. This also enables this kind of use case and this kind of like nice UX. So like these ideas are like talking about how we can take like the old version of Ethereum and start to improve and replace different pieces to make like Ethereum work better and the user experience better. Cool. Cool. 20. Cool. Another thing that would be nice is to be able to do like give like a micro UBI to everybody. Give everybody like enough money to make like 10 transactions or something. That like what we could do is we could say anyone who has like a Twitter account with more than this many followers, we're gonna allow you to make 10 transactions. And like in order to do this, we need to have some like privacy, right? Because we don't want to connect everyone's Twitter account to like whatever they're doing on chain. So we're able to use like some kind of semaphore proof or in ZKPs to hide the user, to break the connection between the account and the actual to break the connection between the user, the Twitter accounts and the actual transactions that are being made. And this is another way that we can give like this kind of free transaction to users, and it's a way for us to grow the set of people who are able to use L2 and able to make like transactions there. Cool. Nice. Yeah, another project I would really like to see is to do like an ENS airdrop, that we could make like an ENS subdomain, and then we could allow people on Twitter with a certain number of followers to claim these names for free, because a lot of people are starting to have these, and like getting an ENS name is really annoying because you have to get gas. And like even on L2, you still, I think, need to get gas in order to be able to pay, or even on these like EVM compatible L2s, you still need to get gas. Yeah, so this is like another thing that would be nice, that we can use like this kind of like interrep is a way that you can export your kind of reputation from Twitter, and we can use this with a zero knowledge proof in order to like give ENS names to people. Like these are a bunch of projects that I think we will be able to do on L2 that's relatively cheap, and also is a way for us to like give a lot of access to people who haven't really been involved in crypto before. Cool. Yeah. So another thing that's I think really one of the like nicest things about changing from L1 to L2 is this like idea of instant finality. And the reason that we're able to do this is because we got rid of the miners or we didn't really get rid of the miners, but we kind of like adjusted the incentives for the miners. That like right now on layer 1, the incentives for the miners is to make blocks as quick as they can and to just be really good at setting up ASIC farms. That's their skill set. That's all that the incentives select for. But when we go to L2, it's possible for us to select for other things, right? We're able to select for like people who are good at performing this job of like packing more transactions into a block, being clever about how to format a block, and those kind of things. Yeah, so how can we do this in a decentralized way? Because at the moment is kind of like this centralized way where you have like this kind of you kind of trust the sequencer in order to they'll tell you, oh, your transaction's included, and then like sometime later they'll actually include your transaction. So there's a way that we can do this with like a deposit to get this sort of weaker finality. And the idea here is that you would put down a deposit, and every time a user sends me a transaction, I would sign that. And I would say, here, I signed the transaction. I'm going to include it in this block at this point. If I don't, you can use this as a proof, and you can slash me. You can destroy my deposit. And the idea is that like, okay, if the amount that you're transferring is less than the deposit, it's like they can delay that deposit, but they have to pay. They can delay that transfer, but they have to destroy their own deposit in order to do that. So it's this kind of weaker finality, but it's not like this kind of like ironclad guaranteed. This transaction is sent. But like you can kind of look at that like on like after we do the merge, it will be something similar, that you'll have like finality will basically mean 2/3 of the stakers will get slashed, or else this transaction is final. So it's kind of the same thing. It just matters the size of the deposit. And I think that it's very unlikely that the size of the deposit here is going to be more than the 2/3 of the validator pool. But we can have these deposits in such a way that it gives some confidence to users that the transaction is actually going to be finalized. Cool. Yeah, and this is just important because like we want to be able to do this in a decentralized way as well. That like right now we have like centralized sequencers, and we want to be able to do this in a decentralized way. Cool. Oh yeah, so this is a fun one. So we like one thing that would be really nice is to be able to create the same addresses on different L2s, right? And like there's a way that we can do this. What we do is we can take the create2 opcode, which is a super complicated opcode, but it does this. It allows you to create deterministic addresses, and the deterministic addresses is the address is a function of. Do I have a laser pointer? Yeah, the address is a function of like the 0xF, the sender address, some salt that's controlled by the user, and the actual bytecode of the contract. So the idea here is if we can deploy the same proxy on different L2s, then we'll be able to create the same addresses on both, right? And like what we really want to do is make sure that the same proxies are deployed upon all the L2s. And this is just a really nice UX because we're able to set up on both. And then users, like if I deploy, okay, so there's two really nice use cases for this. One is if I'm deploying an application on a couple of different places, I can have the same address. And that's just nice. It's just nice because it's like less stuff to verify, and it's like easier for users to check and to send transactions and those kind of things. The second place where it's really useful is like if I have a smart contract wallet, I want to have the same address everywhere, right? That's just really, really easy. Because if I have a smart contract wallet and I don't have the same address everywhere, it just can be really tricky to like, oh, you sent me some Arbitrum money to my Optimism address, and I didn't get it, and now I can't get it, and there's not really anything you can do about it. So this is really nice. This is a really nice idea that like, and I think that some of these proxies have been deployed. We just really need to standardize and say, okay, everybody just deploy this proxy in your Genesis state. So yeah, so this is my next slide. What I want to talk about is like the Genesis state of your rollup. So like we're kind of depending here about having like optimistic about having the same addresses or the same proxies deployed, but like we can just include the proxy in your Genesis state. So we don't actually have to deploy it. We can just include that when you set up your rollup. Like when you deploy a rollup, it always has a Genesis state, right? And most of the time it's just 0. It's just completely empty. But you can set up your Genesis state to include other stuff. You can pre-deploy contracts. So like we can do this for create2 proxies, but there's also a couple of other things that we would want to do this for. Like we would probably want to deploy the same bridges in different places. And I guess it's probably actually better if we just deploy the create2 proxy and then we just use that to deploy all of the other addresses. And like we should probably just use that to deploy everything on layer 2. Like that does seem nicer because then everything that you deploy on Optimism will have the same address as what you deploy in Arbitrum. Okay, cool. Yeah. So yeah. I think that like one thing that would be really good, and I'd really like to hear from other people, is about like what else do we want to include in the Genesis state, right? Because this is like I think that we should come up with like a standard Genesis state that everybody kind of uses, so that we're able to have like similar stuff on different L2s. Cool. Oh, do I talk about PL swap? Okay, cool. I don't. Okay, but okay, I'll try and talk about that a little bit at the end. I've got 10 minutes, right? Yeah. Yeah. A little bit shorter. Okay, so let me go a bit quicker. So another thing that's nice, another thing that makes L2 better and can be like deployed on different rollups is this idea of like call data compression or diff compression. So there's like two kind of approaches to doing this. A lot of rollups kind of include this as part of their system. That like Arbitrum has this kind of compression logic that will basically go and they'll take like all of the. So sorry, let me slow down a little bit and give the context here. So when you move to L2, the only thing that you have to, like not technically correct, but almost completely correct, is that like the only thing you care about is the call data. That like computation is basically free. Like that's not completely true, but it's like, it's a good heuristic. And because of that, like it changes the kind of things that you want to optimize for. That like before, like if you look at Ethereum's transaction format, it includes a lot of stuff. It's like to, from, amount, gas cost, gas price, nonce. It includes all this stuff, and a lot of this stuff can be like compressed out. And like this is another thing that changes, and we can kind of make a little bit better, but we also want to have like backwards compatibility. So the idea is that like you don't have to have all of this like redundant data there, because a lot of this data is just zeros. So there's a bunch of different compression formats, compression approaches that we can take to reduce the diff size. One example is here where it just takes out all the zeros. Yeah, it just compresses all the zeros in like Ethereum call data, which actually helps a lot. Like this kind of approach has been applied on Optimism, and I think it's been applied on Arbitrum as well, where Optimism do like this default they use this kind of compression algorithm that does like zlib kind of, I can't remember what it is, but they do some kind of off the shelf compression, and this is like Rollup level compression. But I think that like my opinion is that like we can compress more if we do dynamic compression. And like dynamic compression and decompression basically means that instead of defining this inside your rollup, you define this inside like some kind of smart contract that is a decompression smart contract. If we do this, we can do this dynamically. We can do this for the use cases that we know about today, but we can also do this for the use cases we know about in the future. And like one of the cool things here is being like a block creator becomes about figuring out how to compress call data. And it's another, and like when you get better at compressing call data, it makes transactions cheaper. So this is another thing that's really exciting. That like, but it kind of requires users to switch to smart contract wallets, because when you want to do the decompression, you need to insert something before the signature verification. And like with an EOA, an externally owned account, you can insert something before you check the signature. But if we have smart contract wallets, you can insert something before. And like this allows us to do this like dynamic decompression that can really reduce the call data, because it ends up doing like, we can apply all these really cool compression techniques. For example, address book compressions. So right now you put like an address on chain. The to and the from is an address. It's I think 160 bits. 160? Yeah, you put 160 bits on chain. But like, you don't really need to put 160 bits on chain, because what you can do is you can make an address book and you can map an index to an address. So you can say 0 is this address, 1 is this address, 2 is this address, and then basically anywhere I put 1, you just get this address. And anywhere I put 2, you put this. And like one of the places where dynamic decompression is really powerful is where you have these address books, these address books, but the address books are different for different apps and different use cases. So I can have a block that makes a lot of Uniswap trades, and I have a certain address book with like 1,000 addresses inside. And I have another that deals with like ENS names, and that has 20 inside. And because I'm using address books, it means when I use the 1,000 address book, I have to put like, I don't know how many bits 1,000 is, but I have to put that many bits on. And when I use the smaller address book, I have to put much less on. And this is where the dynamic decompression becomes really powerful. Cool. 3 minutes. Okay, I've got 2 more minutes. So like because we're talking about Optimistic earlier, I wanted to mention another project that we're working on, which is about like the reason that Optimistic rollups are more expensive than ZK rollups is because you need to put more call data on chain. You need to put the signatures of every transaction on chain because they need to be checked in the fraud proof. In ZK rollup, they're not checked in the fraud proof, they're checked inside the ZKP. So if we're able to remove the signatures that we put on chain, we're able to reduce the cost of Optimistic rollup so that it's basically equal to the cost of ZK rollup. And the way that we do this is that we come up with a better signature scheme. Instead of using ECDSA, we use BLS signatures. And BLS signatures are able to be compressed into a single on-chain signature. And this will make ZK rollups and Optimistic rollups like cost competitive. And I think that this is really important like step for the Optimistic rollup community to investigate. So we've implemented this. Jake and James are going to talk about this later today. It's like gas fees getting you down, beat the queues. Yeah. So that's going to be a really interesting talk. And like this is some work that we're really excited about and really want to share with the rest of the community and like get this to a point where people are able to use this in production. Because we're finished our audit, we're doing another one, but we're ready to go. We have an extension. It's really exciting. They're going to talk about it later. Cool. Okay, I think that's all my talk. Okay, so yeah, so conclusion. So we did a lot of stuff. We have a lot of stuff more that we want to do. It's a really important time. We can improve Ethereum a lot right now that we might not be able to do as much in a year or in 2 years. That like once things are changed, they kind of solidify and it's hard to change them again. The other thing is that like all of these projects are not roll-up-centric projects. All of these projects, you don't have to be part of you don't have to make your own roll-up in order to apply these, right? These are projects that are like general. Everyone can use these. It's like it's like a open entry, open source projects are, you can just start and start working on these things. So it's kind of like the infrastructure that exists around Rollup and around the different L2s. And I think that this is like a super important thing. And I think we should spend more time and think more and talk more about this. So yeah, that's my presentation. Any questions or yeah, thank you. Yeah.
Thank you. Good talk. I had a question regarding the Create2, like standardizing Create2 all over the over all rollups. The problem with Create2 is that at least on ETH1 it uses Ketchak. And for ZK rollups, that means it's really not efficient. So my question is like, are you sure that it's worth? Yes, it's a nice usability thing, but your wallet app should be able to keep track of everything. Is it worth the cost, basically, of implementing gates and everything for ZK rollups?
Right. So like you're talking about like ZK rollups that support smart contracts.
Right.
Yeah. Right. Okay. So yeah, this is really nice because I spend a lot of the time trying to convince people that it's important to have like 100% EVM compatibility, and like that involves implementing Ketchak. We tend to implement Ketchak for a couple of other things too. Like Ketchak is important for, like okay, so some rollup. Yeah, you're right. You're completely right that like this is gonna be different on some EVM supporting ZK rollups. It will be the same on others. I mean, it basically comes down to whether you actually implement Ketchak or not. And I think that a lot of them in the long term will implement Ketchak. It's just a matter of time. I think that like, at least for the efforts that I'm involved in, like one of our top priorities is not to change Ethereum at all. 100% backwards compatibility. It's still like a research effort. We still have some stuff to do, but we're making some progress there. And I think that. Good point, but I think that the onus is on the ZK rollups to match the spec. Yeah.
Thanks. Thanks a lot for your talk. I love the way you're thinking about this. I have a very quick comment and then a question. The quick comment is I think that Arbitrum and Optimism are already compatible in terms of address handling, and we would be happy to talk to other teams who are interested in trying to figure out how to extend this more broadly. But more generally, and I think you referred to this a little bit in your previous answer, there is a tension that I think we all feel between wanting to be compatible with Ethereum, because that's what our users and applications want, and it's what we've been doing, versus wanting to be able to innovate, right? We want to be able to innovate. We don't want to break what is already working for our communities or what we've already committed to. And also, as our communities get larger, as the value on our chain gets larger, we feel more and more responsibility to not take risks with the assets and with the applications and users who are already there. So, we feel the urge to innovate, but at the same time, we feel a sense of caution. Not as much caution as Ethereum rightly feels, but still quite a bit. So I'm curious how you'd suggest we approach this.
Ooh, no, that's a wow. Okay. Yeah, I think that like it's really hard to keep things backwards compatible. A lot of the things that I talk about today were things that wouldn't like. Okay, so let's take the bridges as an example. Bridges can be deployed permissionlessly. It can be an opt-in for your users. Similarly, we can have the transaction ordering be different, like the TX pool. The sequencer can just update their logic to include this kind of like transaction abstraction. I think that that's generally my approach, is that instead of trying to, like, it's okay to change the core in some ways, but I think that like okay, so there's two kind of approaches, right? There's going to be an evolutionary approach where you're going to have like what you have right now, and you're going to evolve that over time. And like with that, I think that it's really scary to change things inside, and it's probably better to just build things on top. But there's also this idea of doing like a revolutionary approach where like you make a WASM optimistic rollup, right? There's all these other things where you have like space to innovate, and like it's hard to like. This is one of the things that like I spend some time thinking about is like, will people use that, right? Is the network effect of the EVM that strong that like other people wouldn't use it? But I think that it's like I think we need to continue to innovate, because otherwise it's either gonna just come out somewhere else, or else it's going to be like, we need to be able to have some input into like what the next versions of these things will be.
Yeah, and we ran out of time. So thanks again.
Thank you.